So what we're talking about here is relative velocities. Right, if I'm talking about how the car moved relative to the paper and how the paper moved relative to the ground, then I can make sense of how the car is moving relative to the ground. So the first thing I'm always going to do, we're going to use this formula that we have. That is velocity with an AB subscript. And what that means is, and notice how I'm drawing the arrow over it to indicate that it is a vector. We do have to worry about the direction. It's going to be really important here in a second. But this is the velocity of A relative to B. That's what the AB subscript means. And this is the velocity of B relative to C. And when I add those two as vectors, I get the velocity of A relative to C. So let's do those last two examples we did on the paper using this idea. When we aimed the car straight across the paper, what was the velocity of A relative to B? Well, I'm sorry, let me back up. We need to define this A, B, and C stuff. A is always going to be the thing that's moving relative to the other thing that's moving. I know, real technical language, right? But hang in there, it'll make sense. V is going to be
Is it the other moving thing?
the other thing that's moving, yes. And then C is going to be that which doesn't seem to move. Right. It might actually be moving.
Oh my God.
The ground.
Right. Like the ground of the brown dinosaur. Was the brown dinosaur moving?
No.
Well,
Technically, yes.
yes. In the frame of reference of
The world.
the galaxy, it was moving. And even in the frame of reference of the green dinosaur, it was moving relative to him. But in terms of, it doesn't seem to move because we were in the same frame of reference of it, and so it's kind of the one that's mostly stationary. Right? So for example, in this situation, you have the car moving on the paper, moving on the ground. Who's A?
Car.
The car, because the car is the thing that's moving relative to the other thing that's moving. What's the other thing that's moving?
Paper.
The paper. And then the paper is also moving relative to the
Ground.
ground, which doesn't seem to be moving. In general terms, A is smaller than B, smaller than C. That's not always true, but that's usually true. So let's take a boat crossing a river. What's A?
Boat.
The boat. What's B?
River.
River. What's C?
The ground.
The ground, yeah, the other side, the bank or the ground. Now, C is usually the ground, but it's not always the ground. For example, I could have an ant crawling on a remote control car on an airplane. What would A be? The ant. What would B be?
Car.
The car. And what would C be?
Airplane.
The plane. Right? Make sense?
C.
All right. So then Let's keep this because we're going to use it.
Are we writing on our notes?
Not yet. All right. So again, let's get back to this example. When the car went straight across the paper, how fast what was AB? I mean,
It was the car compared to the paper.
yeah, it's the car moving relative to the paper. And it was who? 0.1 meters per second east. So VAB was 0.1 meters per second east. What was BC? 0.1 meters per second north, because that's how fast I was pulling the paper relative to the ground. Right? What about, so how am I going to find AC? Well, I'm going to take vector AB and I'm going to add it to vector BC as vectors. So is the answer 0.2?
No.
No, that's adding scalars, right? You can add vectors. So if I take 0.1 meters per second east, and then I add 0.1 meters per second north, then the resultant vector, right, this AC is the sum of those vectors. It goes from here to there, and how do I find it?
Feedback.
Feedback, right. Open up a can of PFAG on that guy, and I get 0.1 times the square root of 2, which is 0.14 meters per second. And so my answer to how fast the car is moving relative to the ground is 0.14 meters per second, right?
No.
No.
Name voice inflection.
I gotta have direction. Northeast. And that would be adequate here because what is this angle? 45 degrees. So 0.14 meters per second at 45 degrees or northeast, or 45 degrees north of east. All those are acceptable. All right? We're getting there. Let's do the second scenario we did back on the paper. The second time, though, what was the velocity of the car relative to the paper? 0.1 meters per second southeast, or at 315 degrees. What was the velocity of, actually, hold on. Well, I'd have to tell you how fast I was pulling it, right? If I pulled it at okay, can you toss me a kind of thing? .07 meters per second. Which direction?
South. North.
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 In other words, at 90 degrees.
What?
That's the paper.
That was the paper relative to the ground. I pulled the paper that way.
Okay.
So how do I find AC? Good. It's AB added as vectors. BC, that will give me AC. So AB was 0.1 at southeast. Whoa, that's horrible. And then if I add 0.07 meters per second north to that, then the resultant, right, AC is the resultant of those vectors, which is from where I started to where I ended, right? And it's equal to how much?
1 squared minus 107 squared.
Right. Square root of that, right? So it's 0.07, right? Because I was nice and gave you a 45, 45, 90 triangle. So VAC is 0.07 meters per second.
No. Half direction.
East,
Or
right?
degrees.
At 0 degrees.
So if we just put east, does that count, or do we have to put at the degrees?
If it's exactly east, if it's due east, I'll accept east.
What do you accept 0 degrees? Or do you 60 degrees?
I prefer 0 over 360.